Hi everyone, welcome to this week's lesson presentation. My name is Bailey Brown, and let's get started. Alright, so this week we're going over Module 5, Chapter 7. So question 1 says to demonstrate how to convert these decimals as fractions in lowest terms and demonstrate how to find the prime factorization of the denominator in each case. So when converting decimals to fractions, there are certain steps we need to follow, which are first to write the decimal in fraction form over 1, multiply both the numerator and the denominator by 10 for every number after the decimal point. And lastly, simplify this fraction if possible. So we will start with 0.225. So step 1, we're going to put this decimal over 1. Step 2, we're going to multiply it by each place after the decimal point. So the first 2 would be the tenths place, the second 2 would be the hundredths place, and the 5 would be the thousandths place. So we'll multiply this decimal by 1,000, and the denominator, the 1, by 1,000. So still in step 2, we're just going to go throughout the math here, and we get 225 over 1,000. And in step 3, we're going to simplify. So this fraction does simplify down into 9 over 40. Moving on to 0.036. So step 1, we've got this decimal, and we're going to put this over 1. In step 2, just like before, we're going to count the decimal places after, or we're going to count the places after the decimal. So we've got the tenths place for the 0, the hundredths place for the 3, and the thousandths place for the 6. So we're going to multiply this decimal by 1,000 and the denominator by 1,000, which gives us 36 over 1,000. So and then step 3, we've got to simplify, and this fraction will simplify down into 9 over 250. So now we're going to talk about the prime factorization of the denominator. In 0.225, we came up with the fraction of 9 over 40. So we're going to take this denominator of 40, and we're going to break it down all the way into prime numbers. So we're going to start with 5 times 8, and bring down the 5 because it's already prime. And we're going to need to break down that 8 some more. So we're going to break that down into 4 times 2. We're going to bring down that 5 again and bring down that 2. But that 2 or that 4 needs to be simplified even more. So the prime factorization of 0.225 is 5 times 2 times 2 times 2. And over here we've got 0.036. So we had the fraction for this of being 9 over 250. We're going to take that denominator of 250 and break it down into prime form. So we'll start with 5 times 50, and we'll bring down that 5 because it's already a prime number. We'll break down that 50 into 2 times 10. 2 is a prime number, but 10 is not. So we'll bring down that 5 and the 2. And we'll break down that 10 all the way into prime form, which will be 2 times 5. So 0.036 in prime form is 5 times 2 times 2 times 5. The relationship between decimals, fractions, and prime factorization of the denominator is that all decimals must be put into fractions before prime factorization can occur. Moving on to question number 2, we've got variables and graphs. So in this question, it says, suppose that the variables x and y are related by each of the formulas shown below. Create a graph for each formula and make up a reason for the shape of the graph. So we will start with the first problem, y equals x over 2. So whenever we set this equation up and with numbers, we've got x is 1 and the y being 1. And these numbers line up like this all the way down to 10. So on the 10 for the x being 10, y is going to be 10 as well. An example for this might be the mileage on your car, because the more that you drive it, the more your mileage goes up. It's not going to go down at all. So that's y equals x over 2. Moving on to y equals negative x over 2. So this is going to be the opposite of the one before. So we're looking for a problem where it will slowly, the amount or the number is slowly going to be going down. And what I could relate to would be the amount of money left on a loan. As you pay it off, your loan, the amount you have left is going to become less. It's not going to become more. And so as we can see over here on this chart, x equals 1 or y equals negative half. And where we've got the x equals 2, we've got negative 1. So this shows to the graph on the right how the line will keep going down. And then we've got scenario 3 where y equals 10x. So what we see here is that x equals 1 and y equals 10. So each number that goes up for the x, we're going to add 10 to it. So when we finally get to x being 10, we're going to have y being 100. So something we might be able to relate to for this problem is a savings bond. Well, the longer you leave it in the bank or the longer you go without cashing it, the more interest it gains. It's never going to lose interest and it's not going to be the same. So it will slowly gain interest and it will slowly get higher, just like this chart. Moving on to part D, we've got y equals x squared. On the chart on the left, we see that x equals negative 5. Meanwhile, y equals 25. But when we get down to 0, it equals 0. So we've got x is 0 and then y is 0. And when we go to positive 5 for x, we've got a positive 25 again for the y. So it's going to make a U shape. And something that I thought was fitting for this one would be the excitement levels during school. So on the left side of the graph, it's when it's pretty high, or it's when it's the highest. And so we're going to think about this as when we start the semester. And then slowly goes down the more homework you have, the more schoolwork you do. And then when it starts getting closer to the end of the semester, you start getting excited again that you're getting closer to being done. So this is what I came up with for the y equals x squared. Question number 3 is percentage of fractions. We're going to start off with, what is a fraction? A fraction is a part of a whole. So as you will see in the next problems ahead, each piece will add up to make a whole part. So right here we've got a square, and it's already divided up into 4 sections with the x in the middle. And we've already been given this one sliver of the square, and that's the one in the red. So we're going to make more little triangles like this to cover the whole box. So we've already got 1, and we'll go 2, 3, 4, 5, 6, 7, 8. So this one little red sliver that we had is going to be 1/8 of this whole square. Moving on to question number 3. So we were already given this image right here, but as you can see in the top left-hand corner, it's not a full box that is filled in. It's only half. So I think the reasonable thing to do would be to cut all of them in half and count those sections. So we've already started with, or we can just count as we go. So we're going to put these lines in to cut them in half. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we're going to count all the little red slivers of this 18 block or 18 section cube, and that's going to be our fraction. So of all the red slivers, we've got 1, 2, 3, 4, 5, 6, 7. So our fraction for this one is going to be 7 out of 18. And for question number 3, again, we've got this circle with like a yin-yang shape in the middle. So if we were to look at this red section compared to this white section, they look identical. So out of this whole part, the red section is going to be half of it, or 1/2. Or vice versa, the white section over the red is going to be 1/2. So if we were to take that red section again, for instance, and had 2 of them and put it in place of the white section, it would make a whole. So this fraction is going to be 1/2. And then now we're on question 4, which is fractions and shapes. So we're going to start with this red shape, and we're going to see how many of those that we need to fill out this octagon. And as we can see, if we put 2 of them upside down together, then they will form one full one of the shape. So one of these trapezoids is 1/2 of the octagon, or 50%. So again, we've got this octagon. Oh, it's a hexagon, I'm sorry. So out of this hexagon, and we're going to be filling it with triangles. So we'll count as we go. We've got 1, 2, 3, 4, 5, 6. So one triangle is going to be 1/6 of this hexagon. And 1/6 is going to be 17%. So you can say that one triangle is 17% of this hexagon. And now we're moving on to this parallelogram. So we've got 1, 2, 3. So one parallelogram in this hexagon is going to be 1/3, 1/3 of it. So it's going to be about 33% of the total hexagon. And we're moving on to this rhombus, and as you can see, they don't really fit in there comfortably, so we're going to say that this one does not work. And same thing for this square. You can't fit more than 1 in here without going outside of the shape. So we're going to say this one does not work either. And now we're on question 5. We're going to move to part 1, and it says, find the percent given A and B, and what percent P of B is A. So I made up a scenario for this one, and it says Oakley's check is $500 for the month. Her electricity bill for the month is $125. How much money is left over after she pays her electricity bill? So we need to figure out what our A, B, and P are going to be for this example. So our A is going to be her check for the month, which is $500. And our B is going to be her electricity bill, which is $125. And then what they're asking for in this question is what percent of 500 is 125. So we're going to do 125 divided by 500, and we get 25%. So her electricity bill is 25% of her monthly check. And moving on to part 2, we have given a percent P and the whole B. What is A if it is P% of B? So given the same problem, we still need to figure out what our A, B, and P are. So our A is still her check, which is $500, and our B is $125, which was her electricity bill. But this time, they were wondering what percent of 125 is 500. So this is opposite from last time. So we're going to do 500 divided by 125, which gives us 4 parts, or 75%. And then this one, it says given a part A that is P% of the whole B, what is the whole B? So this one again is the same question as the first one. It's asking what percent of 500 is 125. So we're going to do 125 divided by 500 again to give us 25%. So this is just a different way of asking the first question. And then on number 6, we've got proportional reasoning scenarios. So we're going to create a table and graph with a rate of proportional change. So my example for this one is going to be making rolls. When making rolls for a set of 8, you're going to start off with 1.5 cups of flour, 1 teaspoon of salt, 4 tablespoons of sugar, and 1 egg. So, and we've got this key down here at the bottom that shows that 8 rolls is going to be in the red dot, 16 rolls is going to be in the blue dot, 24 rolls is going to be in the green dot, and 32 rolls is going to be in the orange dots. So given the information that we just went over for making a batch of 8 rolls, we're going to look at all of the little red dots that are lined up on that bottom row, and it shows how much the flour, salt, sugar, and eggs are needed. And then whenever we move on to 16 cups, or 16 rolls, my bad, then we're going to move to the blue dots, and we're going to need 3 cups of flour, 2 teaspoons of salt, 2 tablespoons of sugar, and 2 eggs, which you can see that the salt, sugar, and eggs are the same each time because we started out with the same amount, so it's going to be multiplied and it's going to have the same amount after being multiplied each time. So those 3 are going to be the same. We're going to see the greatest difference in the proportions of flour for each time. So now we're going to move on to 24 rolls, which is going to be in the green dots. So we've got 4.5 cups of flour, 3 teaspoons of salt, 3 tablespoons of sugar, and 3 eggs. And now we've got 32 rolls, which has 6 cups of flour in the orange dot over here, 4 teaspoons of salt, 4 tablespoons of sugar, and 4 eggs. So the flour has the biggest difference of all of them because that number was higher to begin with. So it's going to get higher each time we multiply it. Well, I want to say thank you for watching, and I will see y'all next time. Thank you.